A curve has equation y equals x squared minus 5x plus 7, and a line has equation y to be 2x minus 3. Show that the curve lies above the x-axis. Then find the coordinates of the points of intersection of the line and the curve. And the last one, write down the two sets of values of x that satisfy the inequality x squared minus 5x plus 7 less than 2x minus 3. Okay, now looking at this given question, solution. Okay, we are given an equation of a curve and equation of a line, where the equation of a curve is given to be x squared minus 5x plus 7. Okay, A. So the first thing we need to do here, we have to show that the curve lies above the x-axis. When a curve lies above the x-axis, what that means is that, let us assume we have something like this. Okay, so for that curve to lie above x-axis now, that means that we have something like this or we have something like this. That's the meaning. And for a curve to lie above x-axis, that means the range of that function now is greater than 0. Okay, so now to get that, so we rewrite this using completing the square method. So you have y equals x minus, you consider coefficient of x, which is 5, then divided by 2, we have minus 5 over 2. Okay, then we subtract the square of that result, which is minus 5 over 2 squared plus 7. Okay, so you have y to be x minus 5 over 2 all squared minus 25 over 4 plus 7. So this is x minus 5 over 2 all squared minus 25 plus minus 25 over 4 plus 7. That's minus 25 plus 28 over 4. Okay, so we have x minus 5 over 2 all squared minus 25 plus 28, that will give us 3 over 4. So which implies that, now when you look at this now, okay, there's something we call vertex of quadratic function. Vertex of quadratic function is of this form, x minus h squared plus k. Okay, so that is why I used completing the square method there, so that we can derive something like this. Alright, so in vertex, the coordinate of vertex is denoted by h comma k, and that is the turning point of it. So what that means is that if you are to get the vertex of this, I mean the turning point of this function, so it is minus 5 over 2, sorry, that should be 5 over 2 then comma 3 over 4. Okay, so this 5 over 2 is the value of h, which is the corresponding value of x. Then k here is 3 over 4, which is same as the value of y. So for your x to be positive and y to be positive, that means the point must be above x-axis. And of course, the turning point here is at the first quadrant, because only at first quadrant, that's when you get positive value for x and positive value for y. You can see this place is positive here, and this place for y is positive. So whenever you get a point in this region, you must have positive value for x and positive value of y. So this shows that the curve lies above what x-axis, because the turning point or the vertex here is above x-axis. So which we obtain that to be 5 over 2 comma 3 over 4. Okay, that's the solution to the first thing there. So the next one is B. We have to find the coordinate of the points of intersection of the line. Okay, so don't forget we have the equation of the curve to be y equals x squared minus 5x plus 7, and that of line we have that to be 2x minus 3. Okay, so we equate this now, so x squared minus 5x plus 7 equals 2x minus 3. So we rearrange this, you have to rearrange this in terms of quadratic equation, so that you have x squared minus 5x minus 2x plus 7 then plus 10 plus 3 equals 0. Okay, so this is x squared minus 5x minus 2x, that's minus 7x, then 7 plus 3, that's 10, okay, equals 0. So what happens next? Product of 10 sum of minus 7, so we can actually make use of minus 5 times minus 2. This will give us 10, then minus 5 minus 2 is minus 7, so which implies that x minus 7 and x minus 2 equals 0. Okay, this is 7. Now this is x is equals to 7 or x equals 3. So x equals 2. So we've gotten two values for x. We now need to get values of y using each of the value we have for x here. So we consider equation of line here, which is y equals to x minus 3. We can make use of the curve as well, but I prefer to use the equation of a line here. So when x is 7, what happens to y? So we have y to be 2 in bracket of 7 minus 3. Okay, and this is 2 times 7, that's 14. 14 minus 3, that's 11. So the first point now we obtain that to be 7, 11. Okay, so for the second point, to get that, what will happen here? Oh, sorry, there is a mistake somewhere here. This should be minus 5 minus 2. Sorry, it should be minus 5 minus 2. Okay, so this has to be 5. Now we consider this to be 5 as well. Okay, sorry about that. So we have 2 times 5, that's 10. 10 minus 3, that's 7. Okay, so this is 5, 7. Okay, so we consider the second value of x when x is 2. Okay, so we have 2 times 2 minus 3. So 2 times 2, that's 4. 4 minus 3, that's 1. So the second coordinate now is 2, 1. So we can name this to be A and this to be B. So these are the 2 points of intersection. Okay, so C, write down the sets of values of x that satisfy the inequality. Which inequality? X squared minus 5x plus 7 less than 2x minus 3. What that means is that we are looking for the value of x that will satisfy the equation such that the equation of the curve is less than that of the line. That's the meaning. So we have x squared minus 5x plus 7 less than 2x minus 3. So the first thing you have to do here is to rearrange this in terms of quadratic. So you have minus 5x minus 2x plus 7 plus 3 less than 0. Okay, so x squared minus 7x plus 10 less than 0. So don't forget, we have similar expression here above. Okay, so just that this is a quadratic equation and the other one is quadratic inequality. Okay, so by factorizing this, we obtain x to be minus 5 x minus 2 less than 0. Okay, so what will now happen here? We can make use of number lines here to get the solution to that inequality. I prefer to use number lines. We can use graphical method as well. Okay, but let's use number line. So the possible value here, we have 5 and 2. Okay, so this is 2, this is 5, minus infinity plus infinity. So now we consider numbers in the range of 5 to infinity. All right, just pick any number in that range. Let's pick 6. You can pick 7, you can pick 10, anything. In fact, you can pick 5.1. So let's pick 6. So we pick 6. So 6 minus 5 here, you have 1. 6 minus 2, 6 minus 5, then 6 minus 2. So 6 minus 5, that's 1. 6 minus 2, that's 4. So this is 4. So we don't actually need the value. All we need is the sign of the results we obtain here. Is the value a positive number or negative? That's what we need, not the value exactly. So, and it is obvious here that this should be positive irrespective of the value you pick. Okay, so now let's pick a value in this range 2 to 5. Let's pick something around 3. If you put 3 here, you have 3 minus 5. Okay, then 3 minus 2. And from this side down, 3 minus 5, that's minus 2. 3 minus 2, that's 1. So this is minus 2. So this is negative irrespective of the value you pick in that range. And the last one here, minus infinity to 2. So numbers less than 2. So we can pick minus 1 or 0. Let's put 0 there. So that's 0 minus 5. We are putting it here, don't forget. Then 0 minus 2. So minus 5 times minus 2, and this is 10. So this is positive. Okay, in case of next time, you don't actually need to check everything, provided that the arrangement of the number is correct. All you need to do is that you interchange the sign. If the first one is positive, the next one will be negative. As you can see, positive, negative, positive. If the first one is negative, then the next after it will be positive, and like that. Okay, so now when you look at this factor, why do we have to do this? When you look at this, we have x minus 5, x minus 2 less than 0. This implies that product of these two factors is negative. Yes, for something to be less than 0, that means this result is actually negative. That's the meaning. So now we look at the negative region here. So negative here is between 2 and 5. So which implies that the solution to that equation is in the range of 2 less than x less than 5. And that is the solution. And what that means is that it is only when you consider values of x in the range of 2 to 5, that is when this quadratic equation be less than this linear equation. So if you consider values outside this range, it will give you contrary results, meaning that if you consider something greater than 5 or something less than 2, the equation of this curve will be greater than the line. Okay, so if you are just joining us for the first time, kindly click on the subscription bell so that you'll be notified whenever I release a new video. Thank you.